lab and shift table by SAS programming. We know laboratory evaluation is very important tools in the clinical trial study, and lab table and shift table is two of the most important tables in the SAP documents. It requires to compare the baseline and each visit of the patient's parameters value and get the basic descriptive statistic. It's also derive the baseline from multi-visit parameters value and catch the each time's visit value and get the change from baseline and represent in the lab and shift table. It also normally use repeated result for analyzing. 3 steps involved in analyzing lab data. Create a second level data to containing original lab data and get the baseline information and a flag needed to identify whether the record is to be used for analyzing. Provide a big list for lab data and also list the lab data by patient, by site, or by treatment. The table for lab data can hold a different type of parameter type. In this example, we use hematology lab parameter. Other lab and shift table will use different medical data as parameter type. In this example, coding SARS, I need to load the raw data of the hematology. In here is called a herma data XML file and XLS Excel version, and 14 column. The first column is called lab data is record multi-visit date for the one patient's visit in a clinical study, and combined with a visit numeric number, we can get the baseline value for each lab parameter. We can also use this to get each visit serial number to point to the lab data to do the lab data calculation and shift table output. From the third to the number 12 is 11 column for the 11 variable in lab data. The last column is subject ID. We use a subject info data set to restrict some patient. In here, we want to hematology study, lab and shift table study, to restrict that all the patients belong to the safety population. And in implementing SAS code, I first use proxical to load the two raw data, hermo data and subject info data. And when merging, I use right join to keep all the subject info tables to mark that all the patients, his or her safety criteria is equal to 1. That's keep all the patients in hematology study is belong to the safety population. And when to use a macro is easily to be reused, and I use a macro to define the summary for the descriptive statistic. Inside the macro, I define the number of non-missing value, mean and standard deviation, median, point maximum and minimum value, format the output consequently. And with the small macro, I also build the whole lab 1 macro that I can select for each visit test compared to the visit 0 as a baseline. I can get their name and parameter, and inside I get each column of parameter as a lab date to do in the do loop to finish their descriptive statistic calculation. After that, call the macro by the different treatment. You can see here I do for I call the lab 1 macro based on treatment 1 is anti-cancer 0, and treatment 2 anti-cancer 1, and also I combine treatment 1 and treatment 2 to get a lab total. And for the output, we can see here as we see we get a anti-cancer 001 as treatment 1, and we have a baseline for statistic for non-missing value, mean, median, and visit 1 also for statistic value. This is WBC, RBC, and the last one is the BA SOS, totally 11 column, and we get a each visit, some visits missing here until visit 10, and then visit 20. So that's a table 1 output. And we also get a treatment 2 that has 9 non-missing value, baseline for statistic, and visit 1 for statistics, and last one is the BASOS. Each one contain 4 statistics. And back to our calculation, we need to consider lab 2 table. We only add additional record. That's a new row. It's called a change from baseline of each visit, and we use a return to get the baseline when the visit is equal to 0, and then we minus each value, get the change. So that's added to the new row. We get a new output here. Yes, that's a lab 2 table. Beyond lab 1, we have baseline for statistic. Each visit for statistic, we have visit X change from baseline. See here, after visit 1, we have visit 1 change from baseline. After visit 2, we have visit 2 change from baseline. That's a derived value from deduct original visit n minus baseline. So that's a second table. The third table we do is that's a shift table that count the categorical data changing. First, we format the data as the based on range, low, normal, high as a character. Then we get the range we use the mean value minus and plus 3 times the standard deviation. We get the range, then we divided each variable belong to low, normal, and high range. Then we use a proc frequency procedure to count the data, summarize the data, calculate frequency output. When this done, I call this macro again and get the third shift table. In here you can see we have a in each unit we have a 3 times 6 data output. We can track the change from each parameter, range from low to keeps low, range from low to normal. In this unit, we see all the 9 tables keep in the normal to normal, and this treatment 1, this one has 8 record stay in normal to normal, but 1 change from high to normal. So maybe that one is efficient or more valuable in the patient's parameter value. And we can see that visit 5, there's a 3 keep from normal to normal, but 1 change from high to normal. That's total the shift table we are living here. We need to understand that mean minus or plus 3 standard deviation is normal range. That's a third table output. In this count, we also know that macro and SQL is used and defined more efficient, and we also count the the missing value and derive baseline.